Welcome to Affinity Designer. In this video I'll be talking about constraints, a feature introduced in version 1.5. Constraints control how a child object behaves when you resize its parent object. So let's first set up a parent-child object relationship. Click on the snapping icons arrow and, from the preset pop-up menu, select Page Layouts with Objects. Then on the Tools panel, select the Rectangle tool. Hold down Shift and Command on a Mac, or Shift and Control on Windows, and then drag out to create a square from the middle of the page. Click this icon here, so our next object is drawn inside this square, and then draw a smaller square in the middle of the page, setting the colour to red. On the Tools panel, select the Move tool, and then on the Layers panel, click the arrow next to this item. This grey square is a parent object, while this red square, which is easier to select from the Layers panel, is a child object. Now, let's display the Constraints panel, where most of our work will be done for the remainder of this tutorial. Go to the View menu, then to the Studio submenu, and select Constraints. The outer square on the panel represents the parent object, otherwise known as the container. In our on-page scenario, the container is the grey square. The inner square represents the child object, otherwise known as the nested content. In our on-page scenario, the nested content is the red square. Before we make any changes in this panel, let's see what the default behaviour is. Select the grey square and resize it using the side handles. Notice that the red square also resizes both vertically and horizontally. If we undo the resizing of the grey square by selecting Undo from the Edit menu, I'll actually be undoing quite a few actions during this video, so I'll make a note of the keyboard shortcut for the Undo command for future use. The shortcut will differ depending on your operating system. If we select the red square again, we'll see that resizing occurs because the scaling arrows on the Constraints panel are solid and white, indicating that the red square is able to scale. We can then switch off scaling by clicking the arrows. They will turn dashed and grey to indicate that scaling is now disabled. Now, if we resize the grey square, the red square moves but does not resize. You can, of course, enable scaling for one direction only, and you'll see the red square only resizes in one direction as the grey square resizes. Let's disable scaling for the red square so we can discuss anchoring. If we resize our grey square, you can see that the red square floats freely within. Instead, we can ensure particular sides of our red square remain a constant distance from the corresponding side of the grey square. We refer to this as anchoring. Select the red square and then click this outer line on the Constraints panel. Now when we resize the grey square, the red square will stay a fixed distance on the left, but still be free to move up and down. Of course, you can set 2 anchor points, and the red square will honour anchoring in both directions. It's worth noting that if you anchor content on opposite sides, as I have here, the red square is forced to resize to honour the anchoring on both sides, even if scaling was disabled. This situation is indicated in the panel by a dashed white scaling arrow. Finally, we'll look at these 2 icons here. They provide control over aspect ratio scaling when a container is scaled disproportionately. So to show how this works, let's remove all anchor points. So currently our square is unanchored and does not scale. If we switch on scaling, the red square now shrinks and grows as the grey square is resized. And it resizes proportionately when the grey square is resized proportionately. If we click this icon, which we call min fit, the red square will still get smaller or larger if the grey square is resized proportionately. However, with min fit switched on, the red square will get smaller compared to its original size as the grey square gets narrower, but it will not get larger than its original size as the grey square gets wider. The only time the red square will increase in size beyond its original size is if the grey square is later made taller. This icon, which we call max fit, works in the opposite way to min fit. Min fit and max fit can be applied even if scaling is only active in one direction. To sum up, constraints determine how the contents of a container react when a container is transformed. Remember, a container is anything which has content nested inside it. A container can therefore be an artboard, layer, group, or, as we've seen in our example in this video, an object. And content is anything which can be nested, including individual objects, groups, or layers. The example in this video was intentionally abstract, so I could show you how constraints work and all the options available to you. How you use constraints in your design work is now up to you to discover for yourself. However, if you're interested in examples of how constraints can be used in specific design scenarios, check out our other video tutorials. And as always, thanks for watching.